And welcome to the Desk of Ladyada.
Hey everybody, and welcome to another Desk of Ladyada. It's me, Ladyada, and I'm here at my desk this evening. Just had some tasty dinner, and it's time to do a little bit of electronics work before I retire to bed and dream of electronic sheep. Tonight, I will be doing a little bit of IoTuesday, where I basically noodle around with Internet of Things type stuff. Tonight I'm going to be doing a sample test on this sample I got. This is actually a recommendation from Mr. Ladyada. Somebody emailed him and said, hey, check out this really nice IoTrelay.com Acdc control relay. We carry something similar to this in the Adafruit shop called a power switch tail. And power switch tails work wonderfully, but some people want to have more than one outlet, or they want to have normally open, normally closed, different ways, or maybe they want to control it with AC. Well, this handy AC-DC relay has an IEC plug, so you can use it in any country. You just swap out the standard IEC plug. It does have only US connectors here, but maybe that's okay for the stuff you're doing. And it has 4 outlets. So let's check out what's going on with this control relay on the overhead.
Before we do that, Ladyada, I'm Nimbus, the friendly cloud entity.
Hi.
What's Internet of Things? I want all your data.
The Internet of Things is, well, for me, it's when I get to connect cellular modules, radio modules, maybe even just Ethernet to sensors and data control so that you can store data on the internet, or send an email when your basement gets flooded, or send an SMS message to change the color of your Christmas tree. The whole system of interconnecting your electronic projects using basically the internet or another sort of network, maybe even a ham radio.
Would you ever sunset services?
I would not sunset
Talk
service.
about the incredible journey we've had before we turn it all off.
I would never say what an incredible journey we have before we got purchased by Google. That's never going to happen.
All right. Well, that's all I got.
Okay, thanks.
All right, I'll
Thanks,
be
Nimbus, the friendly cloud entity. We also have our Iot Bill of Rights that we wrote and signed, which we believe kind of encapsulates the kinds of rights and expectations people should have when using IoT services.
Or you can just give me all your data. It's safe.
Go away, Nimbus.
Wow.
I'm going to go test this sample.
Bye-bye.
Okay, so I got one of these, and it's made out of plastic, not metal, but that's actually kind of good because it means you're not likely to have to worry about grounding the enclosure. It's nice and solid, and there's 4 outlets here. These 2 are normally off, and these 2 are normally on. And then you plug this into your power, so that's all good. And then to control it, there's this terminal block, and this is one of those removable terminal blocks. So if you want to wire it up, you actually remove this, screw in the wires you want, like I have it connected up to an ESP8266 Huzzah. And then when you're ready to rock, you plug it in. I think this is optically isolated, but I'm not sure. I'm going to look inside. I'm pretty sure there's at least a flyback relay, but we'll open it up after I do some basic testing. Okay, so I have my lamp, as you can tell, it says lamp, plugged into here. And then let's go to the computer.
Sorry, I'm back. When you say lamp, do you mean Linux, Apache, MySQL, PHP?
No, in this case, I actually mean a lamp, like a light bulb thing, like this one lamp.
All right.
In fact, we're not even using PHP for this stuff. It's actually being done in Ruby on Rails.
All right. Later.
Go. Okay. I have the ESP8266 programmed with my MQTT demo example, and it's pretty much the default example that we have. It looks for a feed called on-off button, and it reads the subscription data, and if it gets off, it turns the relay off. If the data from the subscription comes back and says on, it turns the relay pin on. That's it. It just turns the pin high or low based on what it gets from the MQTT subscription. And we've got tons of videos and tutorials about MQTT, so check those out. And all this is doing is it's in a loop. I have a lot of debug data going on. Right now it's just pinging every like 5 seconds just to keep the connection alive. And this is my dashboard. I'm not using the slider in this case. So there's a slider, but it's not actually connected to anything. But what I will use is this on-off switch. So let me get this closer to me so you can see it. And I'll click off and give it a second. It'll turn the light off. Click on. And it'll turn it on. So that's the basic Adafruit I/O, just on-off switch to a relay. And it pretty much just does exactly what you think. It turns on and off the relay. The pin goes high, relay turns on, pin goes low, relay turns off. Very simple. So I'm pretty satisfied. I mean, I know it works. I was able to trigger it from 3.3 volt logic, which is pretty important to me because a lot of the boards that we carry are 3.3 volt logic. So let's take this apart and see the construction quality, which is something that's pretty important to me when selling something that does high voltages, mains voltages. So we can go to overhead. Okay, so I'm going to turn this off by unplugging it. And I'm going to plug in the lamp elsewhere. Thank you, lamp. I don't need the relay connectivity because I'm just going to be taking this apart. So I'm going to unplug this. Thank you, ESP8266. And take this apart. Pretty much everything we sell that connects to the wall or has to do with more than about an amp of current, I like to take it apart and look at the build construction. Rarely is there an issue. I mean, I've seen bad construction, but rarely with high voltage devices. But you know, it's good just to see like what's going on, and you can look for little details that kind of give you a sense of the quality and care and engineering that goes into the product. Even something as basic as this relay. So, did I get all of the? Oh, I see. It's actually this sticker that's holding it. Okay, so yeah, you can use 3.3 volts to 60 volts DC or 12 volts AC. It has a safety CPI tested, which is lovely, but I'd still like to check this out. And this is mounted from this side. And I really prefer like these sorts of enclosed relay outlets. I mean, not only because of their mains power, but you know, they're you know, a lot of people when they're doing main stuff, it's not unusual for them to have sort of water in the area or you know, dirt, or maybe it's like somewhat exposed to the elements. So anything that protects your wiring is good. I mean, I've seen a lot of projects that just have, you know, a suicide cord, basically an extension cord, cut, spliced, and connected to a relay. And it's very easy for a wire to come loose. And in this case, the only wire that could come loose is a low voltage wire, which is fine. It's unfortunate because your project won't work, but there's little risk of, you know, a high voltage wire coming loose and then shorting out to something else, either damaging it or damaging a person. Okay, so here is the construction. So on the bottom, what I like to see is all the power traces are nice and big, and they have melted solder on them to help them pass even more current. So that's kind of nice. It's a common thing. And the traces, the leads of the relays and the relay and the outlets is cut nicely. And you've got all the grounds connected, so that's good. There's these grounding plugs here. They all connect to a nice big ground. So that's good. And this looks like this must be the hot. Okay, so that's kind of nice. And also you can see here, there's these little cutouts. So this is to keep isolation between high voltage sections. When you have this much gap in between the high voltage sections, you're pretty much good to go. This doesn't have, this isn't isolated from here because this is ground. So there's no concern about this being close to these contacts. But this is like, you know, the hot line. You want to keep this isolated. And if, because of the width between the tracks, it can't be this narrow. You know, there's mathematical calculations you can do based on the PCB material of what the creepage, how much clearance do you need between traces. Adding a slot will help you achieve that isolation. So that's very good. If you don't see that, make sure that you at least have a very big isolation. Also, you want to have proper FR4. So in this case, you have FR4, which is really nice, not paper phenolic, if you can avoid it. I mean, sometimes you'll get paper phenolic, but I prefer FR4 quality. Also here on these outlets, you see it says no AL, it says CU. So these are copper contacts. And I prefer copper contacts. I'm not sure why aluminum would be better. Copper is usually more expensive, but I think it gives you a much better connection. So that's good. Here is your relay. Don't know this company, but you can probably look up the data sheet, and it can switch 30 amps or past 30 amps on the normally connected side and 40 amps on the normally open side. Which is interesting. Usually it's the same, but you know, perhaps there's some mechanical reason inside that the normally closed section maybe doesn't have as much clearance. Maybe it's more likely to, maybe it has a smaller contact. I don't know. And then this 30 or 40 amps, of course, is before derating, depending on what, you know, this is for a purely resistive load. And if you look up the data sheet, it will tell you how to derate, and also depending on whether you're using AC or DC to switch, it might make a difference as well. And then, okay, so over here you just have like a pretty simple resistor LED to tell you it's on. You have a capacitor here. This is a full wave rectifier. And this is to, oh, I see. So this full wave rectifier is actually used to power the relay. So you can see it's connected here, and this probably goes to the negative, and then the full wave rectified signal is used to power the LED. So you just put a really big resistor in series. And then it's also used over here. And then this is I can never remember the name. It's an MOV? I can't remember. And then this is a very big capacitor. So these are little protective circuits to protect the input of this before it goes to the two relays. That's kind of nice. And then over here, looks like you've got some rectification as well. There's two. Maybe I'll bring this down because I'm getting close. There's two 1N 4000 ones here, so it's going to give you some sort of rectification. And maybe, actually there's 3 diodes, so maybe it's a full wave. And then maybe there's a diode on the bottom, so unclear exactly. But maybe there's a full wave rectifier as well, because this can be controlled by AC, so this might be converting AC to DC. And then over here, we have a KSP44. Look up what that is. KSP44. Okay, so this is an Npn transistor that can handle 400 volts. Okay, sounds right. So this transistor, I mean, I'm not going to trace out all the connections, but probably this signal comes in, and because this can be up to 60 volts, and it can be also AC, it's full wave rectified by these 4 diodes. There's a filter capacitor to convert this input signal from AC or DC into definitely only DC. And then that signal is used to switch this transistor. Probably one of these resistors is a base diode. So this turns on and off the rectified signal from here to power this coil, because this coil needs 48 volts DC. So it definitely, at least, so it definitely, even if you give it 3 volts AC here, you only want the signal to control the transistor that turns on and off the higher voltage. And that's because it's probably cheaper to get a coil that's 48 volts than to get, it's going to be hard to get a 40 amp relay that runs at 3 volts. It's just unlikely. To move that much current, maybe your armature is very large, you want a higher voltage. So yeah, this is, there's no, the only thing I can't quite tell is, this says ISO, which makes me think it's isolation, but it's on the bottom. And this part says LE 13352. I don't know if I'll be able to look that up. LE 13352. No, that's not part number. LE 13352. No. Maybe LE.
There's some Russian side.
No, I misspelled
What's
it.
going on there?
Now I've got some weird Vatican
Got some
thing.
stuff for the Pope.
LE 13. No,
Postcodes.
I don't know what this is, but I think this might be because it's called Opt1. It's probably an opto isolator. Maybe? I don't know. I can look in the specs to see if they mention opto isolation, because then that would explain why it's called ISO 1. And there's also another MOV here. Yeah, this is MOV 1, MOV 2. And then that goes right into the relay. So yeah, it's probably isolated. Maybe the output of the transistor, so it probably only has to drive the transistor, or maybe this voltage gets rectified, gets put through the opto isolator, and then drives the base of the transistor. But at least you're not connecting directly to the relay. That's not possible since it's a 48 volt relay. I think the first version of the power switch tail was direct connect, and you had to have a transistor driver, and you had to fly back diode. With this, that's not necessary. That's all done for you.
Someone wrote the words opto feedback.
Opto feedback. I don't know. Yeah, see, this I don't know.
Yeah.
Maybe I'll look up opto feedback, what that is. But yeah, and then this LED lights up when this is activated. So I like this. There's a lot of really good signs here. The things that you don't see on a lot of relay control boards, input capacitors, MOVs, input LEDs, control LEDs, isolation, nice quality plugs, and really good solder design. So this is definitely something I'm liking this. I like this one. This is definitely better than I would make it. So we're probably going to contact the company and say, hey, we want to resell this really sweet relay control board. This is from digitalloggers.com. So they made this, and they did a good job.
I'll show the packaging.
Yeah.
And they have IoTrelay.com, I guess, but it forwards to digital-loggers.com / IoT.html.
And it's like a really nice injection
Yeah, they
molded
did a good
case. It's pretty fancy.
Yeah, and is there any certs on this thing that people care about?
Well, here's the thing. This in general, because it's exposed, you're probably never going to get, UL certification.
Yeah, can you flip the back of the box just to see?
Yeah, I don't think there is, and
Yeah. So for all the people out there who...
I don't believe you would ever get it, because anything that controls a relay would never be.
Yeah. So for all the people out there who
Yeah.
have to have UL certified stuff for their shows or whatever, the same for you.
You can't use this, and
Yeah.
I think that if you did, you'd have to get something that's like a pretty intense power pack that isn't, basically the fact that this is exposed, that you can plug in, a relay contact, sorry, a terminal block contact, sort of precludes this from getting any sort of certification. It's just, I think that they're just like, nope, this is not what we do. Which is funny because they'll like approve much scarier 6-outlet power strips. And I think this is built a lot better.
Yeah.
But there's certain, regulations that I'm sure they require. But I think this is very well built. And if the choice for you is between using this and building your own, you should probably use something like this.
This ain't sketchy.
It's not sketchy. And I think that's important. Look, I mean, makers, we do stuff that's, quote unquote, don't try this at home. We use high power. We make Nixie clocks. We solder. We weld. We use power tools. It's all about managing your risk. And if you want to control mains line equipment, this is a pretty good way of reducing your risk.
Yeah.
Okay.
Is that it?
That's it. That's my demo.
Oh, thanks, Ladyada, explaining all the IoT things.
Thanks. Thanks, Nimbus, the friendly cloud entity.
Do you know I have emails, pictures, addresses, social security numbers? People just submitted it. I don't know why. They just trust me.
Well, it's because you're such a friendly cloud entity.
Actually,
suppose.
Nimbus, the cloud entity, didn't say that. Mark Zuckerberg did.
Yeah, true.
And then he called everybody who submitted the information a bunch of dumb Fs. But kid-friendly show, so I'm not going to say it.
Okay. All right. Well, thanks
That's
everybody for.
So look at the terms of service on your Internet of Things service
Yeah.
to make sure you know the dealio.
Okay. All right. Well, thanks everybody for watching. It was a lovely time spent with you testing out this sample. You can pick one up yourself. You don't have to wait for us to carry it. I like it. It has the Ladyada seal of approval.
All right. That's it.
Yay. That's all I got.
That's it. Okay, later. Bye.
Yeah, bye.
Give me your data, all your data.